Good day, everyone. Thank you to the organizers for accepting our paper to be presented in this event. And I am glad to share with you our humble study on sustainable cabbage microgreen production through the utilization of locally available substrates for urban farming. We are from the Mariano Marcos State University, Ilocos Norte, Philippines. With me are my co-authors such as Christian Espiritu, Mika Beniz, Gregorio Balbas, Ira Lilac Puntilan, and Christian Butch Andrew Balbas. Microgreens are tender, immature greens wherein the cotyledon leaves and the first true leaves have emerged. The harvesting can be done between 7 and 21 days depending on the crop species. The following are the microgreens that can be cultivated such as Brassicaceae, Apiaceae, Fabaceae, Malvaceae, Convolvulaceae, and Asteraceae. Even the herbs can be used as microgreens. Microgreens are rich sources of antioxidants, thus it has high antioxidant capacity. The different compounds that we can get from the microgreens are ascorbic acid, carotenoids, tocopherols, and phenolic compounds. At the same time, microgreens are sources of chlorophyll and lutein. Moreover, microgreens are rich in minerals such as sodium, copper, manganese, calcium, magnesium, potassium, and zinc. The production of microgreens in 2021 worth $1,445 million, and it is projected that in 2030 it will be almost double the production. This increase may due to the health consciousness of the consumers. At the same time, there is an increased knowledge of the consumers about the microgreens wherein it is rich in vitamins and antioxidants. It was observed that China dominated the Asia-Pacific microgreens market in 2021 and it will continue to dominate until 2028. The production of microgreens can be observed in different countries around the world such as the US, Japan, India, South Korea, Singapore, Malaysia, and Thailand. This about health benefits and a good market of microgreens. Therefore, it will be a good venture in the Philippines. The table shows you the different substrates about its effect on the growth of microgreens. The substrates studied as reflected in the table are the coco peat, vermiculite, perlite, rock wool, cow dung, and coconut fiber. As we can see in the table, the different substrates have different effects on the growth of microgreens. These are the physicochemical properties of carbonized rice hull or CRH, vermiculite, and coco peat. These are the basis of the study on the use of these three substrates wherein the CRH, vermiculite, coco peat contain phosphorus, potassium, calcium, magnesium, and sodium. At the same time, these substrates have different water holding capacity that could affect the growth of the microgreens. Thus, the study was conducted to determine the growth and yield of cabbage as microgreens grown in different substrates under ambient conditions. The conduct of this study will address the Sustainable Development Goals such as the SDG 1, SDG 3, and SDG 12. These are the summarized methods of the study. The cabbage seeds were sown in separate microgreen trays, and each microgreen trays contained coco peat, CRH, the combination of perlite and coco peat, and the vermiculite. The production of microgreens was done under ambient condition wherein the temperature, relative humidity is 30 plus minus 2 degrees Celsius and 60 plus minus 5% respectively. The duration of the study was until 12 days after emergence or 14 days after sowing. The treatments were laid out in a completely randomized design with 4 replications, and the statistical analysis used was the use of STAR program. To determine the mean difference of the treatments, LSD test was used. This figure shows you that the microgreens or seedling height of microgreens in vermiculite, only vermiculite is reflected at 12 DAE because the microgreens grown in these substrates were harvested at this observation period. There was an increased trend of seedling height as the microgreen matures across substrates. At 8 DAE alone, CRH produced the tallest microgreens as compared to other substrates. There was an increased trend of hypocotyl length as the microgreen matures across substrates. At 8 DAE, CRH produced the longest hypocotyl as compared to other substrates. At 10 and 12 DAE for the vermiculite, there is an increase of hypocotyl length from 6.45 to 6.69 centimeter. This figure shows you that the root length and the total soluble solids are not affected by the different substrates. This indicates that the root length and total soluble solids or TSS had similar of these parameters among the substrates. Irrespective of the substrates to be used, the root length and TSS are just the same with the other substrates. The fresh weight of cabbage microgreens showed significant differences among substrates was observed. CRH and coco peat had higher fresh weight followed by the combination of perlite and coco peat and the vermiculite. In terms of the moisture content, the combination of perlite and coco peat were comparable with each other, and the combination of perlite and coco peat had higher moisture content than CRH and vermiculite. On the other hand, the CRH significantly produced a higher yield than the other substrates but comparable with coco peat. Vermiculite had the least yield, followed by the combination of perlite and coco peat. The percent correlation of growth attributes with the yield of cabbage microgreens is shown in Table 1. The seedling height, hypocotyl length, and the fresh weight per microgreen showed a positive correlation with the yield. This indicates that the higher the seedling height, hypocotyl length, and the fresh weight per microgreen had higher yield. Seedling height, hypocotyl length, and fresh weight are higher, therefore, there is an increase or a better yield of microgreens as compared to those seedling height and hypocotyl length. If they are lower in these parameters, they are contributed to a lower yield. The high yield of the CRH as reflected in the results in the previous slides may be due to the different composition of the physicochemical properties of each substrate. As we can see in this slide that CRH, coco peat, vermiculite have different physicochemical properties, although their common or similarities are the presence of phosphorus, potassium, calcium, magnesium, and in the other substrates it contains sodium. However, it should be noted that each substrate have different water retention capacity as observed in this slide. In the case of coco peat and vermiculite, we can see here that the water retention capacity were higher as compared with the carbonized rice hulls based on the previous studies. Coco peat and vermiculite have high water holding capacity and it will resulted to a lower oxygen concentration. If there is low oxygen concentration, it will impede or slow down the growth of the microgreens. As compared in the CRH, which contain a lower water retention capacity than the other substrates, it had a better growth attributes, taller microgreens, and longer hypocotyl length. Thus, it contained higher yield. This explains why CRH had higher yield as compared to others. Based on the above-mentioned results, it can be concluded that at duration of 8 DAE, the cabbage microgreens can be harvested. CRH contained taller microgreens, longer hypocotyl, thus it contained a higher yield. CRH is recommended as a substrate because of a high yield, but the use of coco peat is also recommended due to its comparable yield with the CRH. The author's future plans are the following: the identification and quantification of the bioactive compounds, the effect of nutrient solution and the maturity, the utilization of light-emitting diodes, and the conduct of sensory evaluation of the cabbage microgreens and other microgreens can be done. We would like to acknowledge the following: the 6th BIS 2024 organizers or the committee for allowing us to present our paper in this scientific event, and also to the Mariano Marcos State University for allowing us to present our paper in this international scientific event. This is the end of my presentation. Thank you.